In number 15, they are asking us to calculate delta G from delta H and delta S, and here's the appropriate equation that will allow you to do that. It relates all three of those. So it should be pretty straightforward. If you're having problems with it, consider this. The delta H is in kilojoules, the delta S is in joules. You might want to change that to kilojoules so that it works better, and it will give you the answer in kilojoules, which is what they want. And the second part, they say if the reaction is not spontaneous under standard conditions, at what temperature, if any, would it become spontaneous? And you remember that to be spontaneous, delta G has to be negative. So we might actually be able to predict if it's going to be spontaneous or not. It may not be possible. You notice that the delta S is positive, and that's favorable for spontaneity, and delta H is positive. That is non-favorable, or not favorable, because it's endothermic, it absorbs energy, so the delta H isn't really helping us out here. When you have two variables that are conflicting, then it's going to come down to the temperature. So you may, when you plug in the numbers, you will have calculated delta G up here, and you'll know if it's positive or negative. If it does turn out to be positive, then it's not spontaneous, and they want you to find out what temperature. And so in that case, you would want to plug in 0 for delta G. Now, you could plug in, you remember it doesn't actually get spontaneous till it's just a little bit negative, like maybe negative 0.000001. That would be barely spontaneous. But that's close enough to 0 that you could just plug in 0 and use it, and then solve for the temperature.